Today I'm going to talk about angles, and I'm going to try to create a poster going through all the different angle facts and things you might need to know for various sort of exams along the way throughout your school time. So let's start with the basics. So we need to understand what different angles are called. So the first thing is if you have an angle like this, it's small, and most of you will know that this is called an acute angle. So just as a way of me remembering this, I use that angle itself as a bit of a C, and I actually write the word acute around it like that. Now what acute actually means is it means it's less than 90. So an acute angle is less than 90 degrees. So it's a small one. Another way of remembering it, if something's cute, it can sometimes be small. So an acute angle is a small angle. The next one is an angle that looks like this, which is bigger than 90 degrees, and that's called an obtuse angle. Now again, just the way my brain works, I find it useful to create little shapes in the word, so I'm using that as the B in the word obtuse. So it looks like this. Now what obtuse means is it means that it's bigger than 90 degrees, but it's not as big as 180. So it's smaller than 180 degrees, which we'll come on to soon. The next one, which you see often in things like squares and rectangles, is your right angle. And again, I'm going to write this, I'm going to use that as the R in the word right angle, and that one is 90 degrees. And then the final one, which is less common, is something called a reflex angle. Now that is when you have either an acute, obtuse or right angle, but you're actually measuring the angle on the other side to what you can see in the first ones. So for example, if I just have an angle like this, it's the bit that I've drawn the sort of circle, the angle mark around the outside there, and that's called a reflex. So I'll write that above. And as you can see, I've put it conveniently in the shape of an R because I'm about to write reflex using it as the R. Now that it means that it's bigger than 180 degrees, but not quite as big as 360 degrees. Now, 180 degrees and 360 degrees, that all is useful because if you have a straight line like that, and we're trying to measure the angle from one part of the line to the other, like that blue little curve is showing, that shows that is 180 degrees. So you will often get asked questions where you have a straight line and they'll say something like, there's A, we're not sure what that angle is yet, and this angle here is 130 degrees, and they'll say find A. Well, we know that the whole half turn is or the whole straight line is 180 degrees. So to find A, you can write A is 180, take away 130, which leaves you with 50 degrees. The next one, as we mentioned earlier with the reflex where it said 360, is if you've got a full turn, so a full sort of full turn or a full circle around a point, that is the same as saying 360 degrees. So again, if we've got any other angle, like if I was to draw this, and let's say that's 30 degrees, and this time I want you to find out what that reflex angle B is worth. Well, we know the full turn is 360. We know we've got that little B section around the outside, and we've got the 30 on the inside. So B is the same as saying 360 degrees, take away your 30 degrees, which is 330 degrees. And that's your B. So they're the basics when it comes to naming angles and things that you might find useful when it comes to straight lines and circles. The next bit, however, is to do with shapes. So this time I'm going to draw a triangle. Now we're going to talk about the total angles of a triangle. So all of the red angles that I've just drawn there, what they do is they add up to 180 degrees. Now that's just something to learn, because the next bit, we need to know that. So if I was to then draw a quadrilateral or a four-sided shape like this, what that does is that adds up to 360 degrees. Now, again, you can learn that, but there's another method of thinking about this, is that if you were to connect one of the corners or vertices to the other corner of vertice, like so, with my dotted line, you can see that I've created a triangle here and another triangle here. So we've got two triangles which are both worth 180. So we've got 180 degrees there, 180 degrees there, and 180 add 180 is 360. So that's another way of thinking about it. If I was to then draw a five-sided shape, so we go up by one side each time, so we've drawn our pentagon here, you can again turn this into triangles. So if I do a dotted line to show we've got one triangle at the top here, which is worth 180, draw another one here, we've got another triangle here worth 180, and another triangle here worth 180. So that one, if you add up your 180s, adds up to 540 degrees. So I'll just write in underneath what all of the angles add up to. Now you're going to begin to notice a bit of a pattern. The pattern is that we're adding 180 degrees each time. Now that's a good way to remember it if you're thinking about shapes that don't have many sides, like your 3, 4, 5, 6-sided shapes. But sometimes you might have a question where they say you have to work out the angles of, say, a 12-sided shape. So there's a formula for this. Now the formula is you have the total number of sides and you subtract 2, and then you multiply that by 180. So our formula is number of sides take away 2, and we times that by 180. So for example, if we think about our five-sided shape, so if we're thinking about this pentagon here, so for the pentagon, it would be 5 take away 2, which is 3, and then we times that by 180, which equals 540. So that's this pentagon here. How about then if you've got a 12-sided shape? Now, not many people are going to just know how many, what all the total angles add up to in a 12-sided shape. So that's where this formula comes in useful. So 12 sides, that's what we'll write here. So again, we put it into our formula. So we go 12 take away 2 times by 180. So that's 10 times by 180, which means that the total angles add up to 1,800 degrees in a 12-sided shape. Now that's useful because if they then come to asking you what one of those interior angles in that 12-sided shape is, well, you've got the total angles, which is 1,800, and you can divide it by however many sides you've got there. So 1,800 divided by 12. Now I think that's the majority of sort of the basics of angles that you'll see. I will be doing another video talking about various rules when it comes to finding interior and exterior angles in shapes in the future. But hopefully you can use that as a bit of a revision poster, and I hope it's really useful for you.